Okay, the lesson covered here is graphing angles in standard position. Okay, and again, starting off with the bell work, number 1, which way is counterclockwise? So again, I'm going to see these on a coordinate plane. What I want to see is how directionally where they go. So if I start here, let's say, counterclockwise would be the way a clock would go. It would go this way. Okay, you come all the way around and continue. Okay. Same thing for number 2 here, counterclockwise. If I started here, okay, and I put the hour hand or minute hand, whatever one we want to consider it to be, counterclockwise would be going the opposite direction, so up and around. Okay. Number 3, the first part of number 3 should be fairly easy because you've talked about this a significant amount of times in the years past. However, the second part there is probably a new concept to most of you, if not all of you. Okay, so how many degrees in a full circle? There are 360 degrees. And radians is a different measurement. It's the same kind of idea. It's just a measurement of a circle. It's used a lot in things like calculus. Okay, so it's actually 2 pi. It's just 2 pi. That is not 2 pi degrees because it's in radians, not degrees. Okay, moving on to the notes, just a few pages here, 8 pages in total, so 7 pages of notes. So here on page 2, okay, angles in standard position consist of 2 sides. The first side is the initial side. That is the side that lies on the x-axis and does not move. Okay, so if you noticed on the bell work, I put that darker line on that positive x-axis. I need to see that on every single one of these problems. Anytime that you're graphing something in standard position, I need to see that line because that line on the positive x-axis is my initial side. That one does not move. Okay. The second thing there is the terminal side. So that's the hand that actually moves. That is going to move to the position that you want to form the angle that we're desiring. Okay, and I'll explain that more in a minute. Determining the path of rotation, you're going to go clockwise if I give the angle as a negative angle. Okay, you're going to move counterclockwise if the angle is given as a positive angle. Okay, think about it this way. If I go down or clockwise first, if I think about things as a downer, then I'm thinking negatively. Okay, and if I think on the opposite there, if I think up, then I think positive. Okay. Types of angles here. Again, this is one of those things where at times I can hardly believe that I get some of these questions, but I get them, so I might as well go ahead and answer them. How can you tell if something is given in radians or if it's given in degrees? Okay, there are some cues that we like to try to give. For instance, in degrees, you should know it's degrees because we give that little degree symbol. Okay, that's that little circle that's up in the upper right-hand corner of a number. Okay, radians is given in radians if I have a pi symbol attached to it. All right, there would be no degree symbol, it would just be the pi symbol attached. Okay, for the purpose of this section, I'm going to give you things in both radians and degrees. However, my suggestion is this: don't work with radians. Okay, anything that I give you in radians, I'm going to ask you or recommend to you that you convert into degrees because that's easier to work with. All right, so to do that, to change an angle measurement from degrees to radians, I would multiply by pi over 180. Okay, and to change it from radians to degrees, again, that's going to be highly recommended for this section and most of the unit. Okay, you're going to multiply what I give you by 180 over pi. Okay, and I'll show more as to why. Right, but again, this would be highly recommended that on the back page where everything is given in radians, that you would convert it to degrees so that you can work with it a little easier. Okay, so the last 4 pages here are just examples. I give you one positive degree value. I give you one negative degree value. I give you one positive radian value. And then I give you one negative radian value. Okay, the radian value I'm actually going to alter a little bit on the negative one, because everything that I give you, I actually give you a nice denominator to work with. And on that one, for some reason, I gave a not so nice one. So I will modify that when we get to it. Okay. So what are we going to do here? The thing that you're going to do is you're going to do one of 2 things. You're going to either add or subtract 360 degrees. Okay, so if I have 1,250, that is a large enough positive number that I can just subtract. Okay, if I subtract 360, I get 890 degrees. If I subtract 360 again, I get now 530 degrees. And if I subtract 360 again, I get 170 degrees. Okay, this is what I'm looking for. I'm looking for you to get someplace between 0 and 359 degrees. Okay, if you get to 360 degrees, I want you to continue to subtract one more set of 360 to give you 0. Okay, so here 170 is between 0 and 359 degrees, be it positive or be it negative, okay? But that's where I want you to stop, all right? So then I'm going to look at what I did, and I'm going to analyze. I have subtracted 360 1, 2, 3 times. Okay, those are 3 full rotations, and then I have the extra. Okay, so the extra is what you're going to graph as far as your terminal side goes. My initial side here, again, I need to see this. Darken that line. I've had some people use highlighters. I've had some people use markers, but be conscious because of the fact that they bleed through the paper pretty good. Okay, so the initial side has to be there. If you're using a pencil or a pen, just darken it pretty thick like I did right there. Okay, and then make sure you put an arrow at the end of it. All right, again, I'm going to be picky on these. Then the terminal side at 170 degrees. So if you pay attention to how I modeled this, I don't have this all labeled on the graphs when I do the homework. I just give you this. So you have the choice of doing this and labeling or not doing it. Okay? If it's given as a positive value for degrees, then it starts here. As I go here, again, I'm going up counterclockwise. So I start at 0. And as I come around, I hit 90 degrees. And then I add another 90, I get to 180. I add another 90, I get to 270. And then I get that full circle of 360 degrees. Okay? We're again plotting 170 degrees. So 170 is just above the 180. Okay? Things to understand here. I am not giving you a protractor. If you have one, by all means, go ahead and use it. But I'm not suggesting that you even go out and buy one. I do want you to pay attention to it, that instead understand that here I'm at 170 degrees. I'm only 10 degrees off of 180. So if your line here was, let's say, up here instead, that's a major problem. Okay, and that's a major problem because, again, that's not obviously just 10 degrees. Okay, so my blue line here is a little bit better. Okay, then continuing on to the actual graphing portion of it. So we have 1, 2, 3, 4 rotations. So I start here. Again, this is my initial side. And I'm going up first. I'm going to come up and around. That's 1. Come back up and around. That's 2. Go back up and around. Then that's 3. And then I have that extra that I have to finish out. So I come back and around until I get to this line. And then draw an arrow there. Okay, so 3 full rotations. When I look at it, I'm going to go through it and say, okay, I've got 1, 2, 3 full rotations. That matched the number of times that I subtracted 360 degrees, and I'm at that 170. I see arrows on the end of all my lines, okay? The initial side that I've drawn, the terminal side that I've drawn, and the rotation showing me which direction of rotation. Okay, that's all you have to do for these problems. It's as simple as adding or subtracting 360 degrees. Okay, moving on to the negative one here. There will be times, I guess let me go ahead and preface this. There will be times when I give you a small enough number that is already between 0 and 360 or 359 that you don't have to do anything to. You'll go straight to actually graphing it. Okay, so I'll show what I mean by that when I get to the simplified version of this. Okay, so here, again, since this is large enough negative, I'm gonna go ahead and just add 360. Okay, and you're not going to be able to use a calculator with these, so let me go ahead and show what I would actually suggest here for the purpose of homework. My suggestion would be to pretend that this is 1025 and subtract 360. When you do that, you will end up with 665 degrees. I would subtract then another 360, which would give me 305 degrees. Okay? And then because it was negative, I'm not going to take everything, I'm just going to reverse the sign. So this would be negative, positive, negative, positive, negative. Okay? It's really difficult for a lot of people to add to a negative number, but it's not so difficult to subtract. Okay? So here, we just kind of compensated for that. Okay? And gave ourselves an option that would be feasible for most of us. Okay? So here, let's say again, going back to my comment just before I started, if I had just the 305 degrees, the negative 305 degrees, okay, I would graph that initial side, and I would go to 305 degrees. This is 270. 305 is 35 degrees off of that, but directly in the middle here is 45 degrees. So I'm not quite in the middle, but I'm pretty close, okay? And because this is negative, I'm going down now, so if I was just the 305 degrees, I would start here. I would come up and around, and I would stop right here. Okay? However, again, continuing in this problem, I have two full rotations because I subtracted, or added here, 360 degrees. So I can't stop there. I have to start here. I come up and around, that's 1. Come up and around, that's 2. Come back and around and finish it out. Okay, and then that's the end of this problem. Okay, so now 1 positive and 1 negative in degrees. Moving to the radians. Okay, and again, my suggestion here is to take what you're given and to change it from radians to degrees. So I'm going to take this 13 pi over 4, and I'm going to multiply it by 180 over pi. And the reason I give you something like this is, again, because this is a non-calculator portion of the test. You should be able to take 180 divided by whatever this number is fairly nicely, okay? If I take this and reduce, this gives me 1, and this would give me 45 degrees, okay? My pi's also cancel out. So I end up with just 13 times 45. Okay, if I take 13 times 45, I get 585 degrees. Okay, so then from here, we do exactly what we did on that first problem. We just start taking and subtracting 360 degrees. So minus 360 would give me 225 degrees. That is between 0 and 359 degrees. So I'm going to go ahead and stop. And then I'm going to go ahead and graph. So here, notice that my model has this written out as radians. But again, I can just change that. So this is now 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Okay. So understand the relationship between all of these. At 225 degrees, I draw my initial side. 225 is directly in the middle between 180 and 270. It's actually 45 degrees. So like I said, directly in the middle. Okay. 45 degrees off of 180. I have one full rotation because I subtracted 360 one time. So I start here. Again, positive, I go up first. I go up and around. One, and done. Okay. Moving on to the last problem here. Again, I'm going to modify this one. In the denominator here, you'll notice that I have a 7. And again, on all the worksheets, I actually give you a number in that denominator that's a nice number to work with 180. So I'm going to change this to a 6 instead of a 7. Okay. From there, then I'm again going to multiply by that 180 over pi, because I want to change it from radians to degrees. When I do that, the 6 and the 180 would become 1 and 30. My pi symbols would cancel out. So then I just end up with negative 23 times that 30, which gives me negative 690 degrees. Okay, and again, now it's large enough negative that I can add 360. So if I add 360, that gives me negative 330 degrees. Okay. And then again, I graph that. So again, over here on the model, I have this as my radians, but again, I can change that. This is now negative 90 degrees. This is negative 180 degrees. This is negative 270 degrees. And this is negative 360 degrees. Okay, I have one full rotation, and then I have the extra of negative 330. So I have my initial side. My terminal side is now negative 330 degrees, which is only 30 degrees off of here. So again, 45 degrees is directly in the middle. I don't want to go that far. Okay, and then I have one full rotation and my extras. So I start here. It's negative, I go down first, coming around, I have one full rotation, and then I finish it out. And then there. Okay, so that's all you're doing for this section, and we'll use this later in the unit as well. Okay, as always, if there's any questions, comments, or concerns, please feel free to reach out to me.